here we are. We're going to look at row 7 and 8 for the create task rubric. Row 7, the requirement is that you select a piece of code that is a student developed abstraction. Okay, so we're going to look at some examples to see what would earn a point, what would not earn a point for this piece. And then row 8 explains how the selected abstraction manages the complexity of the program. So basically what that means is you're going to explain how it simplifies things. So instead of having lines and lines and lines of code, you've looked for repeated code that you could make into a function. You've managed the complexity. Okay, so let's look at some examples, and the responses from the College Board are written here also. So we'll just go over these. This one is a definite no. If you look at this, it's an on events. That was not developed by a student. This was not developed by a student. These are all built-in things that go along with the JavaScript. So if you're using all built-in stuff, you are not showing your own student-developed abstraction, okay? So you get 0 points for row 7. Row 8, no, because it doesn't show how this manages complexity. It's just a single bit used in a single place for all we know, okay? Okay, this one says it's not a student-developed abstraction. On events do not count as student-developed abstractions. So be very, very careful that you don't use your on events for your abstractions. They make a big deal out of that. Does it explain any kind of complexity? Not really, because it's a single portion of the program. A single event handler is always a bad choice. Okay? Okay, example 3. Has potential. It did not earn a point for row 7 because the code identified doesn't show a student-developed abstraction. It shows calls to what might possibly be student-developed abstractions, the update score, but since those weren't inside the rectangle, you don't get credit for them. Okay, the reader would likely focus on the on event and not award the point. So had this person shown us their update player turn function and their update score function and included that with their rectangle, then it could have earned a point. Okay. And again, does it explain how it manages complexity? Without these other functions being in that rectangle, it's just going to be discounted. Okay, so this had potential if they had captured, in addition to this piece, if they had included in their rectangle the update player turn and the update score, those other functions, because those probably were student written. Okay, here's example 4. So the only thing they included in the rectangle, now remember, the readers are only going to look at your rectangle. They're not going to look outside in your whole program and think, oh, they meant to be talking about this. No, they're just, they're looking at thousands and thousands of these. They're just going to look at what you put in the rectangle. So be very careful about that. And also, you cannot put your whole program inside the rectangle. Just saying. Okay, so this earns a technically yes. I would give it a no, honestly, because the pieces in here are not student developed algorithms. I mean, this is a function, but I think you could do better with what you highlight there. Okay. Also, it's only called once in the program and so it's not really managing complexity because you're only calling it one time. Number 5. College Board says this would be a borderline call. The code in the rectangle does not contain a student-developed abstraction. The student may have been attempting to show how it manages complexity by including 2 different places in the code that call it, but a harsh reader might say no because the on-event handlers are not student-developed. So anytime your reader sees on-event and on-event, they're going to, a big no bell is going to go off in their head when they're reading your project. So be careful about using that. Does it manage complexity? If identified correctly, the set button props is a good choice since the function is called from several different places in the code. Okay, so it's possible that you could get a point for row 8 on this if you explain this correctly. You could say, well, it manages complexity because a function was written to set the button properties, and then it was called 2 different times. So every time it's called, it will execute this function. Example 6, we finally get to a yes and a yes. Let's see why. They did not box the on-event handlers. They put a box around their function of update score. Why did it get the row 7 point? Let's see here. The student developed abstraction is inside the rectangle. Furthermore, the written response can make reference to places in the code where the function is called with different parameters to demonstrate how it manages complexity. This function is also strong because it has a parameter. It's easy to show with a contrasting argument why not having a parameterized version of the function makes things more complex. Okay, so in the rectangle, the get point for row 7, this is a student-developed abstraction. In other words, this is a function that the student wrote, okay? When they're writing about, in the written response, when they're writing about how it manages complexity, they're pointing out that this function is called from other places in the program. And yeah, so it doesn't have to be a big deal. Okay, just the big takeaways here. Do not use on-event handlers for your abstractions that you're highlighting, putting a box around. Use a function that you wrote for your program. Okay? All right. Hope that helped. Make sure to watch the video I posted yesterday, or Friday rather. He's basically just going over the AP document, but since he's taught the class for a long time and has probably also been a reader, he does mention some things that are some good points. So make sure you spend the time listening to that. This is it for today. Tomorrow we'll look at narrowing down your create task project. I'm keeping these days hopefully simple for you and not heavy on work, because I know you've got a lot of classes you're juggling right now. So anyway, I hope you're doing well, and I will see you on Google Classroom.